So, hi there, people. Welcome to ElixirKenya's third webinar this year. So, today we're going to be talking about Elixir or BEAM Concurrency Primitives, and we're going to be led by John Invictus. So, he's going to take us through today's session. So, I'd ask if anyone has any questions, we can keep them till the end of the broadcast, just so we couldn't interrupt his thought process or anything like that. So, if there's nothing else, I guess we can start. John, karibu sana.
Asante, thank you. Thank you, Getty. Can everyone hear me? Just a minute.
Yes, we can hear you.
What about Paul?
Hi, Paul.
Paul.
Can you hear him?
Yeah, I can hear you.
Awesome.
Okay. But you are just two. Can we wait or just continue anyway? So let me just share my screen. You guys, you can like interactive talks maybe. If let me see, like Paul, what did you expect from this talk? Something like that, so that just to manage the expectation. Ella?
Maybe what I expected was how Elixir implements concurrency. Because if you look at the way concurrency implemented in different languages, I think Go uses other things. So maybe that's what I expected. Yeah.
Yeah. What about who else? Getty. What did you expect?
So I think it's basically the same thing, how concurrency works in Elixir. Yeah, so BEAM is a little bit general. So I was thinking maybe you'd talk about Elixir because I'm a little bit familiar with Elixir. So I'm not sure.
Yeah. Anyway, I will be using the word beam or elixir anytime. So let's start. So the scope of this talk will be mostly based on you will learn how a beam achieves its concurrency and how that works under the hood. Then you learn about beam processes since they are the building blocks of concurrency. Then you learn then I will just give out concurrency in general. Then there are some things I won't touch on because it's more about primitives. So I'm saying that I won't touch on gen server, supervisors, or any generic server processes. Anyway, there's somebody who has his camera mic on. Then introduction. Beam or Elixir or Erlang is so good at solving the below issues, recovering from runtime errors, increasing hardware resources without redeploying the code. That's scalability. Then run code in multiple machines so that others can take over if one machine crashes. That's distributed. That's making the system distributed. So, in order to achieve the above, BEAM provides a unit of concurrency called a process. This is a building. I've repeated myself, but process is the building blocks of concurrency. Yeah, and you should remember that these processes are not the same as the OS processes, since they are lighter and they take a shorter period, like just a few milliseconds to get spun to be spun. So just a minute. Just a minute. So Let's continue. So, how is the BEAM? What is the BEAM architecture? So, how is BEAM architecture for processes or for concurrency created or done? So, if you look at my diagrams here, you can see CPU1. These are cores. Let's say you have a machine like your Dell or your HP. It has several cores. So these CPUs represent 4 cores. Then the beam itself, the whole beam runs in a single OS process. Then that single OS process spawns as many threads as their cores. Example, in my case, we have 4 threads. And so each thread supports its call. Let's say this is thread 1 supports call 1. This thread 2 is supported by call 2, and like that. If you have 4 cores, you have 4 threads spawning from that single OS process. Of course, for this happens so that the Elixir can take advantage of the whole system resources. Yeah, unlike other languages. So each thread has its schedulers. So the schedulers, they are in the beam. These are not the OS schedulers, if you know them. So these are generic schedulers that run in the beam, and each scheduler supports its processes. So a scheduler is it's a, what can I call it? Let me just call it an object, although I'm not sure. So I've not found a good name. So it's a object that spawns many processes which you use in Elixir. So let me continue. So this is just a simple explanation of an overview of what I've just talked. The entire beam runs in a single OS process. The process then spawns as many threads as the CPUs. These threads run the specific schedulers. The scheduler is in charge of interchangeable execution of processes. If the process execution time is up, the scheduler is preempted and runs the next process. So a scheduler will manage multiple processes, beam processes. So if, let's say, a scheduler says that each process will take like 10 milliseconds, then that process is running some job which takes longer. That process will be preempted. Preempted means to be paused or interrupted so that it takes another process that runs something else. So let me continue. The next slide. What is a process? So what is a process? Processes are lightweight and they are usually 1 to 2 KB and they take few milliseconds to be created. The theoretical number of processes is around 268 million, but can be increased. So let's say my machine or any typical, let's say, no, let me take something like if you are good at reading new trends in Erlang or Elixir, you notice you must have come across an article that says that WhatsApp runs when it was starting. When they were starting, they were running the whole WhatsApp in a single machine. This is what made in a single machine in real time. And how it worked is that each user, or let's say each user, no, let's say people who are talking to each other were connected in the same process. So every conversation is a single process. And if you look, like, this machine of mine can support to 68 million connections concurrently, meaning that we can achieve soft real time without any issues. Even this machine of mine, I am sure it can connect, like, it can run a software that can run in Kenya without any issues. Uh, Then, so concurrency versus parallelism. So what is concurrency? Concurrency is running multiple process code in multiple different codes in different processes, so that you can so that they can, yeah, it's running multiple let's say you have something like a pool of jobs. You can run each in its own process, so that you can run that code faster without waiting for each other. Then parallelism is when you can, that job can be done faster and can be done in multiple CPUs and something like that. But so the topic here is concurrency versus parallelism. So if you, let's say, because Elixir or BEAM support concurrency, if you made your code concurrent, does it mean that you do your job faster? The answer is no. The answer is no. Oh, I can hear my voice. I can hear my voice. Somebody has his mic on. Anyway, so concurrency doesn't mean parallelism, because if you have a single call, if you have a single call in your machine, it means you have a single scheduler. And even if you run as many processes as possible, the scheduler will just be preempting or pausing so that it executes the another process. So you'll be switching between processes, and at the end, the time that is taken to execute the task will be the same as just running a serial execution without any concurrency. But so in order for the job to be done faster or in a parallel manner, you need to have more than one call, so that this scheduler is working on this process, then these are the other code, the other process is working on, let's say, scheduler 2. So concurrency doesn't mean parallelism. Let's say, so how do you create a process in Elixir? In Elixir, to start a new process, you need to use the spawn function. Yeah, so the function taking an anonymous, not necessarily an anonymous function. Yeah, not taking in a function, but you can use an anonymous function. So here is an example: spawn fn. Then you can try this if you wish. Then, let me just do something. Let's see. If you look at this, oh, shit. Yeah. So this code, which is magic requires practice, this code is run in a separate process. Then the process returns, since you know that in Elixir everything returns something. So the spawn function returns a reference to that process, and that is what is here called PID. So let's continue. When the spawn is executed, it runs immediately, and returns a reference to the process. If you even you have seen here, it hasn't even taken just seconds, and it has returned the magic requires practice. Something like that. So here is another example. Without if you run a code without the processes, if you run this code, it will take like 1 second. Since I've selected the code here for 1 second, so it will take 1 second to return these. What if this is the range, so I've taken from 1 to 5 range, then piped it in a function called each. If I run it, it will take 5 seconds. There is no need of running this, but to save time. So it will take exactly 5 seconds. What if now, this is a simple explanation. The above code will run for 5 times 1 second, since the code is run sequentially in the EX or interactive shell single process. So something to note is that in Elixir, everything runs in a process. Everything. Let's say everything. That's why I decided to create this talk, just so that you can know the processes works. There's no need of you just using the processes without you knowing it. So if in the process, even though I'm saying that a process will help you run code as in a concurrent manner, just remember that each process by itself runs the code sequentially. From if the code it will execute, let's say A, B, C, D until it's done. So if you want to run multiple processes, if you want to run code, don't use just one process, use multiple. That's what I mean. So that's let me continue. So when you add processes, if you add a process, you just add a spawn function. You just wrap the spell function in spell anonymous function like this one in a spawn, because I've said that in order to create a process, you need to use a spawn function. As simple as that. This is auto-imported, so you don't need to write something like import, alias, use, something like that. It's auto-imported. So if you run this code, it will take exactly, if you run 5 processes, it will return the result after 5 seconds, after 1 second, since each process will be running a single code. So if you have 5 processes, each will just do it work, then return, do it work and return. Then you should even note that if you're running data in concurrency, in multiple processes or concurrently, the order is not guaranteed. You should know about that. Since that maybe some work is shorter and each job is done independently. Then here is a simple explanation. The above code will run for at most 1 second, since each code in the loop is executed in its own process without interrupting. Don't worry. My editor doesn't allow grammarly. So without interrupting one another or having to wait for each other. So let me continue next. So let's say you need a process. Let's say you need a process to communicate with one another, to send a message from one process to another. How does that happen? Let me just read, then if I see any additional stuff, I will just add. So processes do not share any memory. So if you want to tell another process something, you need to deep copy the message to it. This is good since it makes garbage collection easy and also prevent race condition among processes. Yeah. So one, the processes in Elixir, they are just blind. They don't know about each other unless you tell them. And if you want to send some data to a if you want to tell process A some process B, you want process A to tell process B something, you need to send it some data, which is called message passing. Then you should know that this data is not shared. If you send it to B, that data is copied to B without any reference to the previous data. This makes it simple for Elixir to avoid this condition. So this condition is when, let's say, multiple processes are consuming the same data. Let's say you have a two processes, one for adding data and the other for subtracting. If you're adding data, then another process, by magic or by anything, some weird stuff, the subtracting process runs, that data will be added, subtracted, and the final data, the final result will be determined by the process that writes that data lastly. So to avoid this issue, Elixir or BEAM just deep copies that data, so that data is only changed by only one process. Yeah. Let me continue, but it brings some other issues, but I will talk about that later. So so how do you tell process A, process B, how do process A tell process B there is data, or how does it do that? So let me read. To send a process a message, you need to take advantage of auto-important function called send. And send takes two parameters. This is send function. It's a function that has two arity of two, meaning that it takes two arguments. That is the PID, the reference from the spawn function, and the message term, the term. So the term is Elixir term is anything that can be stored in a variable. You can even send anything as long as it's somehow it can be stored in a variable. Yeah. So how does message passing work? So when process A, if you look here, I'm saying so process A on this diagram, there is process A and asynchronous, it's saying here asynchronous sending of messages. A message is stored in the mailbox of the receiver and the sender continues it back. Then here you can see the messages. Yeah, so these dots are mostly the mailbox of the process B. Then what else? This is the time. Then anyway, you can see so let me just explain in my own words. So process A, when it sends, let's say, the term or that message to process B will have to receive that. So when process A sends data to process B, that data is stored in the mailbox, just a memory location of process B. Then process A will just continue. It won't wait for anything. It will just send, continuing, without any hesitation, something like that. So after that, so that process B can know that there is some data which has been sent, or to process that data, it will use a function in itself. It will use a function or a clause, which the receive clause, which uses pattern matching to know this is the data that I want, this is the data I don't want, something like that. Yeah. So let me go to a simple explanation that I've written in case I missed anything. When you send a message from process A, this action is asynchronous, such that process A will not wait for process B to respond. Yeah, I've already said about that. Then the message from process A is placed in process B mailbox, and then process B processes it inside a receive clause. Yeah, this one. I will give a better explanation later. Then here is an example, but it's more a pseudocode. It won't run if you. It's just an illustration. So the receive looks like this. It's here. It's still here. Then let me read the next line. The process mailbox is a FIFO, fast FIFO queue, limited only by the available memory. Therefore, the receiver consumes message in the order received. Then I have forgotten to say that. So the FIFO means fast in, fast out. So when a message is sent in the process B mailbox, that data is consumed by fast in, fast out. So if you sent process message A, B, C, D, it will consume A, then try to consume B, then consume C, such like that, and it's still sequential. So even the receive function is sequential. Just note about that. Then the process mailbox in there is FIFO. Yeah, I've said about. So then I've said, remember, message can only be removed from the queue if they are consumed by the receiver process. To consume the message, you need to pattern match them in the receiver method. So there is this issue if your programming processes. Don't forget to pattern match even the unmatchable process messages, because if you don't, they will still be in the queue. So let's say you have sent invalid messages that can't be pattern matched, like 1,000. Then you have sent a good message that can be pattern matched, like one on the 1,001. The receiver will pattern match every time from start. 0, 1, 2, 3, 4, 5 until it reaches 1,001, and it sees, oh, this is matchable. Then it removes it from the queue. Then it stops. If it finds another, if you send another one, it will still start at 1,001 every time. So if you add more, it will start from there, because the receiver, it's more of like a loop. Every time it tries to see if that message is matchable. If it's not, it puts it back to its position and continues with the execution. Yeah, or just wait. So let me just continue. That's why I've said remember. Here is an example. Let me just write some code so that you can feel you are in a programming webinar. Anyway, let me show you example how receive works. I will not write any complex code or I will just write a simple one. So let me send a simple term message to EX interactive shell process. I've said that even this one, what I'm interacting with this is a process. So let me send myself a message. If you want to find the reference of PID of the interactive shell, you can use, or any other process, you can use this. You can use the self. self. No, let me just store that in a variable. So let me call it p equals to then let me send some message. I've said this is in auto imported, so I can say p, then let me send a term. Most programmers I see use the tuple, so you can even use it if you want. So I can say p is let me just px, that's the atom px, then I send. I like using the word magic. So I've sent this message. Let's see if I can receive it. I can receive the message using the receive method. Receive do, then IO. Oh, no. Then pattern match. I'm waiting for data which is of this type. Then px goes to message. Then let's just output that message and say message. What have I puts? Sorry. Now I have to do everything. Received. Puts. Hey. So it should have sent. Jesus. So if it doesn't match any message, it waits forever. I'm not sure why it has waited forever. Sorry. That's why I don't like demonstrating code. Let me just see. Send self. If it doesn't run this time, I'll just move on. Receive, do. Now it's don't know why it does. Anyway, so if you can see that I sent the message with a pattern of okay, then X. I could have sent even the okay only because it's something that can be stored in a variable, but I chose to send a tuple because it has more options. So I sent okay, then with the message X or something X. It's not, you can choose your way of sending data as long as it's a single variable. Even a map, I'm not sure if a map can work, but it's better you use tuple. So if you then X, then I wrote a receive method that waits for data. If there was no data which was found to match, this receive function will run forever. Just note that. Then you can see how it worked. Let me just continue. Yeah, you can see even here. This is some spell from Harry Potter. If you watch Harry Potter, I don't remember how it if I say that stuff in a Harry Potter movie, maybe somebody would start feeling pain or something like that. Anyway, let me just continue. So the process receive functions work like if you have used a case function, that's how receive function works. It just matches the expressions. It tries to pull one message from the mailbox and match it with the provided pattern. Even note that it has said here, note yet they have said that it removes a single message from the mailbox, then tries to match it. that means it's sequential. If no matching message, the receiver function will wait forever. Like when I demonstrated first the receive function, you have seen that it hasn't. It was just waiting. I can just even do here. Receive. Right now, yeah, let me just repeat. Yeah, you can see it will just wait like that until Jesus comes again. Anyway, so that's so if you don't want for the timeout to last forever, you can set a after after clause. So the after clause will run. Let's say if the receive function receives a message, then processes it, then it receives another one. Every time it receives a message, the after clause starts from zero again. The timer on this after clause will start from zero. So if within these 5 seconds, because this is a milliseconds, within these 5 seconds, nothing is received, the process will terminate. That's why you see, like in a, if you have, yeah, let me stop going there. But that's how it's done. If you don't want the process to run for wait for the message forever, you can terminate it after a given time period. What's a good example? Let me give a good example. Like, how would you create a Uber timeout in Elixir? A good example would be to use they are those generic, but in the actual sense, they use something like after. Those generic server processes. But if you are doing it with plain without plain processes, you can use the after. Let's say if the driver doesn't receive any message from the customer or nothing happens, within 5 seconds, terminate the process. Something like that. So anyway, let me continue. So this receive, which has been hyped in this process stuff, how does it work? So the receive algorithm, how does receive work under the hood? One, it takes the first message from the mailbox. I've said the first in, first out. So the process, the code that has worked, which has arrived first. If it's A, B, C, D, so A will be taken first, then tries to match it against the provided pattern, going from top to bottom. That's what I mean. From first A, B, from A, then goes to B, like that. If the pattern matches, it runs the corresponding code. If the first one matches, it will run the code that is under the pattern. If no pattern is matched, the message is put back to the mailbox at the same position where it occupied. So if process A doesn't, if the the message A doesn't match, it will be put back at position, let's say 0. If the 100th doesn't match, it is put back. It's not removed. Just you should know about that. So when you don't pattern match empty unknown patterns, you should, that's why I was saying that you should pattern match everything, because it will, if you're like something like WhatsApp, then you go to create something that is real time and you don't pattern match some things, it will bring some issues of, you have some issues of that the concurrence, the, what do you say, the the code. Anyway, let me just continue. I've started becoming tired. So it will take forever. So let's say I wanted to say, if let's say process A, no, the message A is not pattern match, it's put back. If you have something like Facebook, the WhatsApp, every time it's put back because it was not pattern match, you meet that the FIFO, because it's first in, it's still the first in, you meet that it will start, it will be looping until the millionth, let's say a millionth message, then it pattern matches it. Like that, every time it will be starting at a millionth because there are some things that it was not able to pattern match. So if no messages, so if no pattern is matches the message, it is put back into the mailbox at the same position where it occupied. This trace, this, then it should be then tries the next message. If no message is in the queue, queue wait, if no message in the queue, the receive function will wait for it to arrive. If it arrives, it repeats the processes, the algorithm, as I've said it there. So if an after clause is specified, terminates the receive function if no message has arrived within the specified time. So let me go to the next. So there we have something like, you can, we have something called stateful processes. A process can run forever. Maybe you can create a single process to store cache, although it's not the best thing. So such a process that you create and it runs forever, or you intend it to run for hours and hours, that's what we call a process. A stateful process or a server process. So here is an example. So, and in order to achieve a endless process, you can make it call itself recursion. So after the receive function, it has executed. Every time a receive function is executed, it terminates. To avoid that, then terminating the process. So to avoid that, you need to create a loop. So after, you can see here, I've created the run. It's good when you are creating server processes or stateful process or any processes, you can create interface. This is more, not interfaces like Java or anything. It's just an entrance. That's why this is a function. If I say run, it will return the reference of these, then, but it will return the reference of this process. Then I can send messages and do that. So if you look at this code, I'm spawning a loop. Not, you can call it any name, but I chose to call it a loop so that people can understand. So, and this is a shorter way of, this is like writing like fn like that, yeah, then end, but and let it be just be fancy, yeah, taking an arity of 0 because it doesn't receive anything, we just and 0. So yeah, if you look at this function, this receive clause will be waiting for this. If this message comes and it's pattern matched, it will continue to the next line. If it goes to the next line, it will call itself. You know, in Elixir, recursion is like a major thing because we don't have things like for loops such as that. So recursion is a big thing. Don't worry about it. And so because it won't even affect the performance of the system, even if you have like 1,000 or 1,000,000, if even you have 1,000,000 loops as these processes, they won't affect the system. So don't worry. The reason I will just explain it on the next slide, I think. So a server process loop is not usually resource intensive, as I was saying. Even if I had like server processes like 1,000,000, they won't affect the resource of the machine that I'm running on, because one, if when the the server process is in waiting. When it's no, when it's the receive, the the VM will suspend it, will suspend the state, so it does not waste any CPU cycles. As simple as that. Hence, yeah, then I've just added something. Hence, it's possible to create many server processes without causing any issue with the CPU. That's a plus, I think, because if you are creating a very big system that has a lot of server processes, maybe you need in other languages, maybe you will be required to maybe clean up garbage collection, maybe. So let me continue to the next line. Also note, since server process are just processes, any job you send to it will be handled sequentially, one at a time. It's just another repetition, but you need to know that even the server process, because they are just processes, any data you send to it is handled sequentially. So when you are using it, don't send like a million, because a lot of data expecting it to do it faster, because it's a process. Know that it's a single process, and it will run that data in sequential. So how do you keep the, so let's say now that I was showing you about how to run a process forever. So how do you keep a state? Let's say you want to create a process that calculates mathematics, that people on your web or any system can add data or store data without losing their state. So you can see here, in order to achieve that, you need to add a message on the function that calls the loop. Like I've done here, I've said loop, then I've added a value of 0. So if you look at this, the receive function, if it pattern matches, let's say I've sent a message of increment, then value. If I will receive that data, then say value plus 1. Then you can see here, because there is nothing else which can be pattern matched, this receive function will return let's say if it's 0, it will 0 plus 1, it will be 1. Then that will be the new state. Then this new state, I'm looping with it. This recursion, the new state is added to the top. This is called a tail recursion. And tail recursion doesn't consume resources in Elixir a lot of, or it's almost negligible. So don't worry about it, because it reuses that data. So if I say increment, it will put the new state. Now the new state after this loop will be 1. So if it returns the value again, no, this should be not the value. Actually, this should be something like that. Then I should say, yeah, I wanted it. When I was creating this example, I wanted it to be a map, but so a simpler one is so state. So the new state is like that. So if it's 10, comes here, becomes 11, then the next time the state will be 12, like that, 9, something like that. That's the way you keep state in a process. When can you use this? Maybe you can use this when let's say you're creating your own supervisor, and you want it to keep, of course, a supervisor, you want to go and start creating a database of your own, whatever. It will keep a list of processes which are live. If it dies, it tells the parent process, something like that. So you can use such you can keep state in that way. So if you're tired of using the PID because they are hard, they are not legible, you can use the process dot register. Is it register? Yeah, register. And the process dot register, this is how you register processes so that you can use them in that instance. They are local. This registration register is local. It's not, if you want to use other methods, the other methods, but that is in the scope of the distributed systems. If, let's say, you have this VMA and you have run this process register, you can use that in that machine only. If you go to another machine, you won't see the name of which you have registered. So in order to register a process, you can say process.register. Then if you want to send data, you can just send. Then instead of putting the PID here, you can just say term. The term, But you should even know, guys, that although this is not in that line of the processes, Elixir terms are not garbage collected. So if you want to use the term, use them anywhere in your code. Anytime you want to use these terms, or actually not the term, atom. The atom, yeah. So when the atoms in Elixir are not garbage collected. So when you want to use them, be careful. If you have a big system that runs a lot of users use, you may run out of memory because of just simple things like atoms. So if I want to send data to a registered process, I can use the atom. I can register it with an atom, then send data as I was doing before. So what else? So you can, if you don't want to use funny atoms, which you might forget, let's say, like in my case, yeah, this is the state. This is hopefully everyone can see it. Here, the state, this is a module. You can use the module name. Why? Module names are atoms too. Don't forget about that. You can use a module because a module is an atom by itself. Don't ask me about that a lot. Haven't researched on it a lot. So what to consider? So we're almost ending. So what to consider when using processes? The things that I've said here, I've been saying them before, but so let me say one. The process mailbox is unlimited, meaning that there is no cap on the mailbox of a process. And you know that Elixir uses the whole system when it comes to processes. So this poses an issue when your pattern match. It poses an issue when you're sending a lot of data to the one mailbox without them being processed, or when the process is slow, or it has a task that takes so long. One, because, so imagine that since the Elixir or BEAM thinks that the process mailbox should be unlimited, you can send as many messages as you can until the machine runs out of memory. That's when it knows the limit. Yeah. So that's one issue. So you should consider about that. Then the processes bottleneck. One, processes execution is sequential. Hence, multiple processes sending data to a single process may pose some performance issues. I've said that I've been saying that processes execute data sequentially. So sending a lot of data to a single process, and even remember that Elixir by itself, everything runs in a single process. I've even shown you the architecture there. So even that, if I run everything on this interactive shell, I will have some issues because I will have to wait for so long. So to avoid that, I can subdivide the job into smaller processes until everything works. So then what else? Data is deep copied, and sending a big message may consume runtime. So deep copying, it uses RAM, deep copying. So you can't expect to send like an article of New York Times to a process that will eat your RAM. So make sure that when you are sending data, send it as small as possible. Even don't forget that don't overuse the terms or the atoms because they are never garbage collected. So conclusion, uh, I've choose not to touch on the process linking and error detection. That proved to be so big, and since you know the basics, I'm sure that you can research on it. If not, maybe I can arrange another talk for another day. So thank you. Any questions? I'm done. Hello.
Thank you so much, John. That was an awesome session. I don't know if others agree, but for me, it was awesome.
Yeah.
So, if anyone has any questions or comments, we have a few minutes left, so you can just unmute and then ask. Kisinga, sorry, had some questions.
It doesn't
Kisinga,
have a. You have earphones? Anyway, just a minute.
oh, you're there with him.
Yeah. Just unmute. You are saying that you had a question.
Yeah, so several questions actually. One was let me just scroll through the chat. Is it possible to send a message to several processes at the same time?
Okay. You can mute. So, yeah, it's possible to send several messages to multiple processes. Like, if you look, so if so if you look, are you positioned? So if just a minute, So if you look at this code here, this is just a range from 1 to 5. This one will create 5 processes. It will create something like 5 processes. Then if you want to send data to these 5 processes,
Please share your screen.
oh sorry, I had forgotten about it. So I'm sorry. Okay. So I will do some Google search and some things just to show some to answer that question. So example, I can in this case, let me show something. Let's say the span function will create 5 processes. But if you want to, if this function here, the spell, add some receive function and a receive function, you will create 5 processes. Then instead of each, I use something like map. I will have 5 references to those messages. I will have 5. I will store this. The result here will be a list of PID, PID. Let's say PID. Let's say up to 5. So if I want to send data to these 5 processes, I can write another map that sends data and returns at once. If I want to collect that data, I will have to use a method like, it's called actor method. Actor. Some, if it's raw, do you know these here? I'm doing everything in raw form. This is not the best way, but it will work. So if I send data to these 5 processes, and the message that I'm sending to them has the PID of a collection process, a single process. I can create a single process that will collect data for the all 5 processes that I create here. So anyway, I'm talking a lot, but yeah, it's possible to send data to multiple processes. And like, let's say I can, just a minute, I can show you something like distributed map in Elixir. This is more of, if I'm not sure. You can use such stuff to get, maybe in a weather application, you can create a weather application that pulls location for the weather for 5 cities, each in its own process, then sends that data to you. Something like that. Anyway, it's possible. Just ask the next question.
All right, thank you. Well answered. Don't mind my rookie questions. The other question is about. I'm new to Elixir, by the way. Gab, what happens to the data held by a process when it crashes or something happens to it?
So in Elixir, we have multiple. If let's say a process contains some data, then it crashes. Of course, that data it's lost. It's lost. That data is lost. But since Elixir with has many ways of, but in Elixir community, we encourage such stuff. We call it let it crash, because we have patterns that we can use to recover that data. Example, you can create something like, there is this we call supervision tree. Anyway, I'm going to other complex stuff, but you can for each process you create, you can have a mother. Let's say a mother, let's call it a DB. You can create a DB process. Yeah, you can create a DB process. Then each data which process A or B contains, it's copied in the mother process. So if process A crashes, if process A crashes, it will, next time it restarted, because Elixir restarts. If a process dies, it is restarted. But in order to have those features, you have to use something called supervisor supervisor. Then instead of using raw processes, you can use something called gen server. So if you use these ones very well, you can, there are many examples online to show how to recover from data, because I can even write here like Elixir let it crash. Plus we have runtime databases that support that like Amnesia. We have Amnesia and what? ETS tables. I don't remember. Yeah, something like that. We have logics to support that. I just ask the next question. You can even see understanding the advantage of let it crash term. Yeah,
Well,
yeah,
that's all the
we support
questions.
that. Mm. You have another question?
No, that's it for now. Thank you.
So the
All
next
right, thank
one.
you so much. We're a little bit beyond time by like 6 minutes. So, any other questions? I think you can contact John. You could find him on Twitter at Invictus John, I think, or his number is on the BEAM Kenya platform. You can also find him there. So, thank you so much, John. Until next time, I'll be updating you on the next webinar soon. So, thank you. Bye.
Bye.